streaming, structured APIs, right? They want to perform the advanced analytics, right? They need more libraries, right? More libraries. So they need one powerful unified computing engine, right? Computing engine with a set of libraries for parallel data processing on the computer cluster that is called Spark. That is called Spark. Spark not only for batch processing, you can use for real-time data processing also. You can use the real-time data processing. So Spark is a unified compute engine. Compute engine for distributed data processing or parallel data processing. Parallel data processing. Parallel data processing on computer clusters. Your computer clusters. On your computer cluster. We'll see the especially what are the components are available in the Spark. What are the components available in the Spark? Alright, so these are the especially components, right, components and libraries, especially to the Spark users. The Spark user. The first component is the low-level APIs. The first component is you can use the low-level APIs. That is called your RDD. That is called your RDD. Even you can use the low-level APIs, application programming interface. Also, you can use the component name is called RDD. The component name is called RDD. Right from Spark, the default, right? If you're creating anything internally, it will convert into that RDD. That initial component was right RDD, resilient distributed data set, right? So it is very, very powerful. It is very, very powerful. But each and every component, right? If you're creating anything, right, that internal, it will convert into that RDD. That Spark only, it will convert into that RDD. Explicitly also, you can create that RDD. By developer also, we can create RDDs, or internally Spark also will convert your each and every code into that RDD or some distributed variables, accumulator variables, shared variables. These are also nothing but your low-level APIs. These are that initial. Right, when should I use that low-level APIs? Right, in case in your requirement you want to explicitly create one object. Right, you want to explicitly create one object. Right, from that object you want to take about the resilient distribution data. Right, maybe the requirement you haven't done from a special data frame or data set or some Spark SQL, right? So the requirement maybe you will achieve with only that RDD, not from other APIs, right? Then only will prefer the low-level APIs. Explicitly also we can create RDDs. Explicitly also we can create RDDs, but especially already we have that high-level APIs. We should not create that RDDs. Again, it is a performance issues, right? Again, it's a to overcome especially the low level APIs. So they were introduced some high level APIs. They were introduced high level APIs or structured APIs. So these are the components. So depends on your requirement, you will use. The next one is your structured APIs. Right? If you observe the low level APIs, right, you will not deal with your structured data. Right? The low level APIs only it will deals with only the unstructured data. Only unstructured data, then people will prefer the low level APIs. The next one is called your structure APIs. Structure APIs, right? If you have that any structured data, semi-structured data like JSON or CSV file or Parquet, you have the proper delimiter, right? Proper delimiter, then we'll prefer the structured APIs. We'll prefer the structured APIs. Here from the structured APIs, the components are data frame. So this is only important, only the data frame only important, especially in Spark, because 99.9 percentage you will use only data frame or Spark SQL. Then I'm giving only SQL, not Spark SQL. I'm giving SQL. Your entire requirement, right? Your entire code, the combination of either data frame or SQL. But yes, we have that one more. The latest component is the data set, data sets. But unfortunately, the Python it will not support the data sets. But 90% of people will not use the data sets. But this is the next level of the data frame. But this Python it will not support the data set because it is a type safe type safe variable. It is a type safe variable. It is a type safe variable because especially in the Python everything is the dynamic dynamic data types, right? Dynamic data types, right? For example, if you are defining that one variable but explicitly you're not defining that variable, right? So by default the Python will convert by default Python will create the data type based on your data, right? Based on your data. But the data sets are not dynamic one. The Before creating the data set only you should define your data type. So that's why Python it will not support the data sets. But especially in the real time, right? 99.99 percentage you will use only the data frame plus SQL combination. Only your entire requirement, only the data frame or alternative SQL. Anyway, the complex structured one, right? The complex structured one, all right, will prefer the SQL. Otherwise, we can use the data frame, either data frame or SQL or both combination also. For example, few people, so they will only read the data. For example, that X person is expert in SQL. Right, the step one, he will read the data from the CSV file or some from the Parquet file or from XYZ table. Then on top of it, he will create some temporary tables, right, or main tables. Then he will execute especially the Spark SQL operations. Spark SQL operations. If you are expert in SQL, right, your entire requirement you can achieve with help of the SQL. There are two types of APIs: low-level APIs, structured APIs, or high-level API. From the structured APIs, you will deals with your structured data. Always you will deals with your structured data. That is in the form of the data frame or SQL. Data frame also nothing but it is a kind of your relational database only, kind of your table or kind of your Excel spreadsheet. Means combination of rows plus columns. This is your regular SQL. The data set is a right combination of data frame and RTD. Means you can read the data from unstructured data or you can read the data from the data frame. But Python it will not support the data sets only. We should use the scalar programming, right, to implement your data sets. But you should define your predefined case statement. You should define your predefined your data types because it is a type safe, right, type safe variable. Right. The next components, right? The next components is your structured streaming. Now, these are the different types of components, right? Spark is providing to the users. Spark is providing to the users. This is your structured streaming. In case if you want to deal with any real-time data, right? Real-time data also, yes, they are providing the structured streaming. You can use the structured streaming for not only for batch processing, but you can use the structured streaming also. With the help of the structured streaming, right, you can do the your real-time data analytics. Right? Even Spark also providing some advanced analytics, right? Advanced analytics like your Windows function, like your pivot, unpivot, right? Your collection list, right? If you want to perform any, like your Delta Lake, right? Analytics, Advanced analytics. Even you can perform your merge operation. You can implement your SA type 1, ACD type 2, right? That advanced analytics also, like your Windows function, your collection list, the regular expressions, right? So these kind of operations also available in the Spark. Operations also available in the Spark, right? It is providing the libraries, right? More libraries, libraries and ecosystem. ecosystem. Even you can use the Databricks ecosystem, right? You can use the different types of libraries like Spark libraries or PySpark libraries. Right? Spark libraries or PySpark libraries. Even you can use the Scala libraries. You can use the, especially you can use that internal, right, ecosystem libraries also you can use. The ecosystem, it could be Spark ecosystem, or it could be Hadoop ecosystem, or it could be your Databricks ecosystem, or it could be your AWS, Google, right? Indirectly the Databricks only, right? Any ecosystem also you can use, especially to implement your, especially Spark. So these are the different types of components are available in the Spark. Right here, the main, right, we'll discuss about in detail data frame, SQL, and RDD. Right, but data frame is very very important. In case if your, right, deals with only the structured data, right, structured or semi-structured. Semi-structured means the data is in JSON format, right? Key value pair, like your dictionary, key value pair combination, right? If you want to convert into the structure, we'll create the data frame. That will create the data frame. The keys will convert into the columns, and their values will be converted into the your data points or rows. Right? Maybe you can read the data from the complex nested JSONs also. The complex, maybe one column contains array data, right? One column contains array data. From that array, you want to generate multiple rows. But still, we'll use the data frame. We'll use the, right, good libraries from that Spark to convert your nested, JSON data into the structured, the complex JSON data into the structure. Also, we can use the JSON related libraries or JSON related functions or Spark related functions. We can use, we can convert the complex nested JSON into the structured JSON also possible with the help of the, especially some struct command. We have with the help of the struct command. Moreover, the data frame, right, it is equivalent to your table. Means predefined structure. Table means it is a predefined structure. Right? For example, in any database, if you want to create the table should contain the structure. Right? Without structure, it's not possible, right? Without structure, it is not possible because it is a predefined, right? It is a predefined definition. Right? Table, predefined definition means it contains the schema information, right? Your column names, the data types information, right? Column names, the data types information. Otherwise, it's not possible, right? The same concept they were implemented with the help of the data frame. The same table concept they were implemented in the data frame. But maybe you're reading the data from the unstructured data, from the text file, right? From the text file. Right, yesterday we discussed one example, right? From the text file, you have the unstructured data, right? Maybe PDF file or maybe .txt file. That completely the unstructured data, not the structured. From the data, you want to count, right? You want to count, especially the mango, apple, banana, right? The fruits information you want to count. But the data is unstructured. If it is a structured data, right, based on the columns, based on the schema, we can divide, right, which column contains all the fruits information. Then we'll do the group by, right? We'll do the group by, we'll do the counter, right? Automatically we'll get that information. But data is not in the structure, right? Data is in the unstructured. Then, but how can I read the data from the unstructured? How can I apply the transformations on the unstructured? Right? How can I apply the transformations on the unstructured? How can I use that user defined functions on my unstructured, right? Then we'll create that RTDs. Then we'll create that RTD. So these are the low level APIs. These are the structured APIs. If you're creating your data frame, right? If you're creating the data frame while executing your data frame, it will convert into the physical plants, logical plants. But internally, the data frame also will convert into that RTD. But depends on your requirement. So RDDs are all, these are the, especially that older components. That initial the Spark 1.x version, that 1.x version. So they were introduced only that RDDs. From Spark 2.20 onwards, right? They were introduced the data frame. Means the next generation of that RDD, right? The disadvantage of the RDDs, right? They introduce the data frames from Spark 2.6 onwards, right? 2.5, 2.6 onwards, right? They were introduced the data sets, but the data sets especially best fit for only the Scala programming language, not for Python. So these are the different components of the, especially these are the different components of the your Spark. These are the different components of the Spark. What are the especially features of the Spark? What are the features? What are, I mean, so what kind of especially, I mean, use cases we can implement with the help of the Spark, right? With help of the Spark. So this is your Spark core. This box is your Spark core. Means Spark core means it will support your low level APIs or it will support your structured APIs, right? It will support your structured API. This is your Spark core. Spark core means the Spark core means you will use the Spark APIs, right? Like you will use RDD or you will use data frame or you will use R, sorry, data set, right? This is your Spark core. So this is your Spark core. Right, it will maybe here you can create any type of your APIs, right? Could be RDD, could be data frame, could be data set, right? Could be your shared variables, accumulator variables, broadcast variables, right? So maybe you may use Python programming language, you may use Scala programming language, right? You may use Java programming language, you may use R programming language, right? So this is your enter Spark core. Here the Spark core, you will talk about your master node and your slave node, your master node and your slave node. But how your Spark will execute your jobs? There are three types of deployment models. There are three types of deployment models in the Spark. There are three types of deployment models in the Spark. So these are the especially your cluster manager, your cluster manager. With the help of the last three boxes, with the help of these last three boxes, your cluster manager will execute that your main code. So it is a kind of interface or kind of broker between your especially master node and slave nodes. Your master node, it will connect with your cluster manager. The cluster manager responsibilities, right? Cluster manager responsibilities, right? How many, especially the free worker nodes are available, right? Okay, this code should assign to that which worker. So that is especially the cluster manager responsibility or resource manager responsibility. Here we can use Spark standalone, right? Spark will use the Spark. Right? Even we can use the own the Spark standalone cluster manager also we can use. Spark standalone cluster manager we can use. Otherwise we can use Mesos. We can use this is also, I mean, these are internal, these are the internal, right? These are internal, will not, I mean, connect with either Spark standalone or Mesos or Yarn. These are the internal architecture. These are the internal architecture. Otherwise, you can use Yarn. You can use it Yarn, yet another resource negotiator, yet another resource negotiator. But especially maximum either will internal that architecture will use either Spark standalone or Yarn. So it depends on your ecosystem. Maybe your ecosystem is especially for only the Spark ecosystem, right? Maybe in the Hadoop point of view, right? Maybe people will prefer that Yarn. People will prefer that Yarn. But the Databricks, right? Databricks we may use standalone or Yarn or both, maybe both combinations also we will prefer, right? So the Spark core, right, the Spark core, it will connect to, I mean, it will take the help from your cluster manager or resource manager, right? It will, because it will talk to that initial the Spark standard or Mesos or Yarn, right? It will raise the request. I need to execute this code, right? Could you please connect with especially the slave node or especially that worker node or executor, right? So their responsibility to submit the code to the worker node, that submit the code to worker node, right? Submit the code to worker node. That is the especially the last the cluster manager or resource manager responsibility. The Spark code, your entire your code will be developed here. Entire your code will be developed here. But what are the advantages of the Spark, right? The first advantage, for example, the first advantage, right? The first advantage is your Spark skill, right? The first advantage is your Spark skill, right? Maybe I don't care about that functionality, right? But I want to work on the big data analytics. I want to work on the big data analytics. My data 100% it is a structured data only. The structured data, I don't care about what is RDD, what is the data from, what is the data set, all right? right? Only I will create the data frame. I will create the data frame. The rest of the calculations, right? Once in with data frame equivalent to your table, right? Equivalent to your table. Once we create the table on top of it, your data frame, right? Then that entire year flow is equivalent to your table only, right? Your entire year flow is equivalent to table. If it is a table means it's happily we can execute your Spark SQL, right? But happily we can execute your Spark SQL, right? If it is database related, right? Database related, maybe I want to implement the especially AC type 1 type 2 logic. But how can I implement the type 2 logic? If I want to implement the type 2 logic or type 1 logic, I need that merge statement, right? We need merge statement. Without merge statement, how can I implement? Maybe we can implement, maybe the process is complicated. The process every time we should do that override, right? Every time we should do that override. I don't want to do that override, right? For example, in the simple terminology, the merge statement. So this process is very, very important. For example, I have the data ID, comma, ename, comma, salary. This is my source data, right? This is my target. This is my target. For example, this is my target. So at very first step, the very first time I have the data only in the source, right? I have the data only the source. Very first time I don't have the data into my target, but I want to implement that upset logic. But how can I implement that upset logic? How can I implement the upset logic? Because your data is in that file system, right? Maybe your source is file, target also file. For example, just your source is file, your target is file. You want to read the data from your Azure Data Lake storage, and you want to read the data to Azure Data Lake storage, but you want to implement the especially STD type 1 or maybe upset logic, insert till subdate logic. But how can I implement the especially upset logic? Upset logic. If it is a table, right? If it is a table, happily we can use the merge statement, right? Merge your table using source on your join condition, right? Your join condition when matched, right? When matched, then update, right? When not matched, then insert, right? But these kind of operations we can execute if it is a table, right? If it is a table, your target also table, right? Your target table, right? Your source also table. Or at your target also table, your source also table, the table should be available, right? Physically, then it is possible. But here your target is a file system. Your target is a file system. Target is a file system. Target is a file system. But how can I implement it? How can I implement the merge statement? How can I implement that merge statement? Right? It's not an easy, right? What is the best way? For example, my target is a file system. Right? Here I can't use it merge table. Right, we can use the latest feature, the delta lake, right? The delta lake feature we can use. If it's a file also, we can implement that merge statement. Just assume you don't have the delta lake concept. You don't have the delta lake concept. What is that alternative? What is that alternative? But here you want to implement the especially that upset logic. What's that alternative? The step one, we should read the data, read the data from source. The second step, read the data from target if exists, right? If exists, if it's not available, then you can take that only the structure, right? You can take that only structure, then create right, sorry create temporary tables on 1 and 2, right? On 1 and 2 and 1 and 2, the temporary tables and 1 and 2, right? Implement your SQL, implement your SQL knowledge, right? Implement your SQL functions, right? Or your concepts. Means here you will talk about left gen, you will talk about inner gen, you will talk about which are new records, which are old records, which are modified records, which are no change records, right? Here you will talk about your fourth step, right? Once here all the data is available, right? All the data is available, you will overwrite your target. Over, because in from the fourth step you have the new records, you have the change records, you have the no change records also, right? The three combination, the data is available in the fourth point. From the fourth point, again you can take the data, you can create the target with help of that overwrite operation. Means overwrite means that existing data you're deleting because all the data is available in the fourth step, right? Right, the fourth step data I can take and I can delete that existing file. Right, I can perform that overwrite operations. With the help of these steps also, we can implement that upset logic. But again, you're dependent on your SQL operations, right? Maybe you're not using the merge statement again, you're dependent on your SQL operations. Again, you're dependent on your SQL operation. Maybe you may use the especially data frame. If data frame also, it is equivalent to your SQL, right? In case if it is a table, if it is a delta lake, right, no need to perform these many steps. Happily, we can use the merge table. Right, majority 99.99 percentage in your project, right, majority you will use only the Spark skill, or 50 percentage Spark skill, maybe 50 percentage you will use the data frame, 50 percentage data frame, 50 percentage Spark skill. If it is only SQL related, right, SQL related, right, 100 percentage you will use that only SQL, right? You can create your notebooks with SQL extension, right? If it is only the table information, maybe you're reading the data from the Spark tables and writing the data to Spark tables, right? Writing the data to Spark tables, then happily you will use only the Spark skill. Only the Spark skill you will import your PySpark or Spark libraries SQL related, like your regular expression replace function, some time function, some date functions, some concatenate functions, right? Some pivoting, unpivoting, right? If the functions are not available, libraries are not available, explicitly you will import the Spark SQL, right? SQL is very, very important. 99.99% your all operations you will execute with help of the Spark SQL, because we're the data engineers, we're ETL developers, right? ETL developers point of view, right? Your entire operations, your SCD type 1, type 2, type 3, right? Upset logic, any complex, your subqueries, joins, right? The column level logics, right? The low level filter conditions, pivoting, unpivoting, right? Pivoting, unpivoting, right? Majority will implement with the help of the Spark SQL or data frame, with the help of the Spark SQL or data frame. What is the next use case, right? The next use case, right? The next use case, machine learning, right? Spark, right? We can use Spark or we can use PySpark not only for data engineering, right? Yes, we can use Spark for machine learning also, right? Data scientist also they can use it. Data scientist also they can use. Those are called machine learning libraries, right? ML libraries, right? You can use that machine learning libraries also you can use, right? I mean, the data scientist also they can use the Spark, right? They can use the Spark or they can use the PySpark to implement their machine learning, implement their artificial intelligence, implement their especially predict analysis, their models with help of the Spark. Why they are considering the Spark? Because there deals with a huge amount of data, big data analytics, right? There deals with that huge amount of data. They want to process their models, right, within that agreed SLA. If they're not using the Spark, but how they will distribute their data, right? How they will improvise their loads, right? How they will improvise the loads. That's why, right? Even data scientists, data analytics also, they will use that machine learning. They will use that machine learning, right? Even we have the dedicated Spark R also, right? We have the dedicated Spark. For example, any R developer, right? R developers, the data scientist, right? They can use the Spark R programming language. Like your PySpark. PySpark means Python plus Spark, right? Spark R means your Spark combination, right? Your Spark combination plus your R programming language. Right, Spark plus R programming also, right? R program, this is one type of your library or module, one type of library or module, right? You can use the Spark R also, right? Data scientists, they don't want to use the Python programming language, they want to use the Spark plus R combination. I mean, you can use in the Databricks R programming, but still they want to implement the both combination libraries, they want to import both combination of the libraries, then they can use the Spark plus R combination. Spark plus R combination also they can use. In case if you're talking about any graphics related application, right? Maybe that use case, graphics related unique use case, right? Like your Facebook, like Facebook or Twitter. They want to achieve the proper relationship between the one parent to the number of childs, right? The root to number of childs, right? Then they want to go with the graphics, right? They want to go with the graphics programming, right? Even the you can use the graphics libraries also. You can use the graphics libraries also available in that Spark. If you want to execute any graphics use case, right? Graphics use case, still we can prefer the Spark code. Still we can prefer the Spark code. Even the structured streaming also you can use, right? The real-time data, right? Right, even you can take the structured streaming, right? The streaming data, right? Streaming data means your real time, right? The real time. So this is especially for batch processing. The last box is it will talk about streaming means these kind of use cases also we can implement with the help of the Spark. With the help of the Spark, even the Spark data engineers can use, data scientists they can use, data analytics or data scientists also they can use, they can build their artificial intelligence. In case if any graphics applications also they can implement with help of the Spark, but with help of the Spark. In case if you want to talk about streaming data also, they can use the Spark programming. These are the different types of use cases, right? Use cases we can implement with the help of the Spark. These are different types of use cases are available, right? We can implement these all these use cases with the help of the especially Spark. With the help of the Spark. Right, these are the related the cluster manager or resource manager, cluster manager or resource manager. These responsibilities, right? These responsibilities to execute these responsibilities, right? If you want to execute your code, the cluster manager, resource manager will connect with your worker node. It will select which worker is available now, which worker is not occupied with work. Then it will select that especially worker node or your executor, right? Executor or worker node. Then the code, the request will submit it to the your executor, but the responsibility by your Spark. These are everything internal. I mean, we'll not see, right? These are everything is internal. Maybe from the configuration we can check. From the configuration we can check, but these are everything internal format. But only here, how can I use the Spark, right? Yes, either RDD or data frame or data set, or with help of the Spark SQL, right? With help of the Spark SQL or with help of the R programming language, you should define your code. You should define your code in the Spark terminology or maybe Spark libraries, Spark terminology or Spark libraries, right? With help of the supporting programming language, the supporting programming language. Here, right? You can use Scala programming, right? Scala programming because your Spark also, your Spark programming, your Spark process engine, right? Compute engine designed by the Scala programming language. Maybe in the real time, right? Maybe in the real time, you may use the Scala programming also. Depends on the project. Depends on the project. Right, my previous client, the Unilever, right? So they want to implement entire programming language in the Scala because the project was implemented on 2016, but still they're continuing only the Scala programming language. They don't want to convert into the Python. If it is not available in the Scala, right? They may explicitly use the Python programming language because your single notebook will support multi-language also, right? With the help of that magic commands also you can use, right? With the help of the magic commands also you can use. Otherwise you can use the Python programming language, you can use R, you can use the Java programming, right? Maybe Java you will not see from the Databricks, right? Java you will not see the Databricks, but only Scala, Python or SQL you can use, right? But this is a Spark, right? This is Spark, core Spark, not with the help of your Databricks, right? Databricks is kind of an ecosystem, right? The backend is using the Spark, but from the Databricks itself, if you want to create any notebook, either you can use the Scala or Python or Java programming, right? From the Databricks, only you have three options: Scala, Python, or plus SQL, right? But internal, you can use the Java libraries. You can import your Java libraries, right? Because every entire code it will execute on your Java virtual machine on JVM only. It will internally it will execute on your JVM. But explicitly we can't select. your notebook as a Java, but internally you can, I mean, from the Scala programming also you can import your Java, right? From the Python also you can import your Java libraries, right? In case, for example, you want to deal with some date functions, the date function, maybe those functions are available just as the, maybe just those functions are available in the Java. But what is the best way, right? You should import your Java libraries to implement your date functions, right? To implement your date because internally it will execute your entire code on your Java virtual machines. Java virtual. Yes, if we want to develop any Spark code, right, we can go with any one of the programming language. One of the programming language we'll select because this is not a graphical user interface, right? I mean, the, like not like your ADF, right? Explicitly, you have to type your code, right? Explicitly, you have to select your language and you have to, I mean, type that code, right? Then you should select the right libraries or right API to your requirement, right? Because ADF, we can select all that activities, right? Maybe in the copy activity, it will do the copy from source and target destination. Right? If you want to take, you can get metadata. Everything is a graphical user interface, right? GUI. But internally, you can use the ADF related functions, right? But here, this is not a graphical user interface, right? Everything you have to, I mean, you have to provide your code, right? You have to provide your code to implement your requirement. Maybe if it is reading the data from the source and writing the data into the target, writing the data into the target, right? Then you should select your data frame. Instead of the copy activity, you should select the data frame. Yes, I can use the database utility CP command. Just it will copy the file, right? It will not do the data processing, right? Maybe I want to do the data copy based on my formats. The format is my delimiter, maybe comma separator or pipe separator. But dbtools.fs.cp, it will not check your any type of file it will copy, right? Any type of file. It could be structured, semi-structured, unstructured, PDF, PPTs also you can copy, right? Anything you can copy, right? dbtools.fs.cp, like it is equivalent to your binary copy, right? It will not check that format, right? It will not check that format. It will not check the data type conversions issues, right? Blindly, it will copy paste, right? But if you want to do the data processing, right, like your copy activity, so in the copy activity, why we are selecting it, especially why we are selecting the delimited one, why we are selecting the delimited one, right? Yes, I want to, while reading the data, right, from my CSV file, I want to split the data, right? I want to split the data based on the comma, based on the pipe, based on the semicolon, right? I want to do the cast data type conversions. If the data is not suitable to my data type, I want to ignore the errors or I want to abort that field. I want to abort my process, right? I want to abort that process. That's why we are selecting into the your right format. Now the delimited format, you're not selecting into that binary copy. If it is binary copy means happily we can use the dbtools.fs.cp, but you want to do the data processing. How can I do the data processing from my structured data, the CSV file? Then we'll use a data frame. Means you're using the Spark or PySpark APIs, right? The structured APIs. But if you want to iterate your process, right? You want to iterate your process, you're selecting one of the programming language. One of the programming language you can select. If it is a Scala, right, we'll create the data frame in the Scala language. If it is a Python, we'll create the data frame in the Python language. If it is R, in that R language, we'll create the data frame. But the data frame is the Spark only, but we should select the which language, right? We should select the which language you want to create the data frame. Right? Mean if this is Spark data frame only. But the default language, for example, if it is a Scala, right? While creating the notebook, you are selected Scala programming language, right? While creating the data frame, right, the syntax should be in the Scala. Either of the syntax should be in the Python programming language. If you want to develop any notebook, you have to select any one of the language. Any one of the language means your entire Spark code, right? Your Spark code syntax, right? Either in the Python or in the Scala or in the SQL or in that or the Databricks point of view. If it is a Spark point of view, maybe in the Java, maybe in the Java. But majority, right, libraries are available in the Python as well as in the Scala, right? Scala is having the more libraries. Yes, I'm talking about Spark point of view, not Python point of view. The Spark point of view, right? Scala is having the more advantage than the Python. It will give the good performance than Python because with the help of the Scala only we developed the Spark, right? it is a native language, right? Native language, right? Compared to the Python, but especially in the real time, right? In the real time, 99, 90 percentage, especially nowadays, people are preferring only the PySpark. Earlier, we don't have the PySpark combination, right? Like your Spark plus R, right? Like your Spark plus R, right? Maybe last 3 to 4 years back, right? They were introduced Python plus Spark combination, because majority people are using the Python programming language. They want to maintain the proper collaboration. If you observe here, the structured, right, the structured data, or your data scientist, your machine learning, your artificial intelligence, right, or artificial intelligence, we can implement with the help of that Python. We can implement with the help of the Spark SQL also with Python. Your streaming also with help of that Python. If I want to maintain the proper collaboration, that proper collaboration, that I want to select the only one programming language. The program is common for all the use cases, right? That's why people are preferring the PySpark. People are preferring the PySpark. But especially your old projects, that majority old projects were implemented the notebooks code in Scala programming language. If they want to migrate, right? If they want to migrate, they can convert into that Python programming language. Only the basic changes we can convert, right? For example, the Scala we had discussed, right? We should define always val var, right? Val and var. Right? That is called mutable or immutable. It will talk about mutable or immutable, depends on your val var. But whereas in the Python, it is a dynamic data type, right? Dynamic data type. No need to define any data types, right? No need to, because val var is not a data type. It is a I mean, it is a concept of mutable, immutable. Right? If you're defining that val, it is always constant. The variable is always constant, irrespective if it is map, if it is array, if it is integer, if it is a string, if it is a dictionary, if it is ABC data type, it is always constant. Whereas in var, right, if it is integer also, we can change we can change, but the same concept is not available in the Python, right? Because integer always immutable, right? The string always immutable, right? Only the list is mutable, right? Only the list is mutable, all right? But in the Scala programming language, any data type you can convert into the mutable, or you can convert into the immutable. The concept is available in the Scala programming language, right? That valvar is mandatory in the Scala programming language. Python, it is a dynamical type language, right? Dynamical type language, known to define your data types. So the top boxes are talking about the use cases. There are many use cases we can implement with the help of the your Spark code. The last boxes, it will talk about your cluster manager. Clear, right? Right here we'll talk about driver and worker. Talk about your driver node, your worker node. Right here you will talk about Spark context or Spark session. Spark context or Spark session. Okay, so I mean all the Spark related information, that all the Spark related informations are available in your Spark core. The top box, it will talk about your use cases. Even the second box also will use the Spark skill, but this is one type of use case, right? Only the SQL related, only the SQL related will use the Spark skill. Only that machine learning libraries will import the Spark machine learning or PySpark machine learning libraries to implement your ML algorithms. ML algorithms. Right. Let me open the PPT. Let's see. So these are the Spark features, right? Yesterday we discussed, right? It is a very powerful than your map reduce, right? Your map reduce 100 times faster than your map reduce, 100 times you're faster than map depends on your cluster configuration. If you're defining the higher workers, right, maybe 10 workers, right, 10 workers, right, the backend depends on your Databricks units, it will create that a number of VMs. You can use more than 100 VMs or 200 VMs or 300 VMs also you can use to improvise your performance load. But if you're dealing with a huge amount of data, you want to finish your right data processing, right? You can increase your configuration, right? Even auto scaling also available, right? because it's a very very powerful. All right, you can improvise your, I mean, you can speed up your data loads, you can speed up your data loads with the help of the your Spark 100 times faster than your map reduce, 100 times your faster than your map reduce, because it is a high configuration, high, more powerful caching, right? Because your enter data also you can, I mean, make the data availability into that your driver node or worker node also. From that one also you can, I mean, this is a kind of internal memory location, a kind of internal memory location. You can put the data into that cache. For example, if the data is available in the cache, at fastest access, right? Instead of into your local hard disk, if the data is available in that cache, right? If the data is available in the cache, you can access the data very easily, right? We can access the data very easily. It will give the good performance. If the data is physically available in your hard disk, right, then you need to, I mean, invest too much of your networking, right, too much of round tripping, right, to reading the data from hard disk and coming into the your process, again reading the data from the hard disk coming into the your especially your process. It is a time taken process, right? If the data is available in the hard disk, let me put it the data into the my cache. From that cache, right, from that cache I can perform my transformation. From that cache I can implement a operation, then you will see the good performance, right? The deployment, right? The deployment is you enter your Spark code, you can deploy in the three models: Spark standalone, Mesos, or the end. So this is a kind of your resource manager and cluster manager. Means with the help of those any ecosystem, you can deploy your Spark code. Not only for real time, not only for batch processing, right? You can perform the real time data processing also, right? You can do the real time data processing. The polyglot means it will support all the programming languages, right? All the programming languages like your Scala programming language, R programming, Python programming, your SQL, your Java, right? Different types of programming. Even you can talk about your especially, I mean, percentages, shell commanding also you can execute. For example, I want to implement, for example, I want to implement some libraries, Python libraries, right? Maybe I want to execute from that Spark, right? From that Spark, I want to execute my Azure Data Factory pipelines. So by default, it's not possible, right? By default, it's not possible because Data Factory is different, your Databricks is different, right? But how can I execute? I can execute my Databricks notebook from Data Factory because the connectors are available, right? Because if you don't have the Databricks notebook, right? If you don't have the Databricks notebook, then it is not possible, right? Then it is not possible. Then I should think about that alternative, how to execute my Python programming language with the help of that maybe Azure functions or maybe the custom activity, right? The customer. Then I should think about some run books, right? Automation account. With the help of that automation accounts, I should think about alternative. But already the connectors are available, right? The connectors are available. The Databricks connectors are available, right? We can create the notebooks. Happily we can use. But what about the Databricks? Databricks is not a graphical user interface, right? It is a command interface. Means everything you have to write the commands, right? Everything you have to write the commands. But how can I execute my ADF? If you want to execute ADF, what kind of connectors are available? What kind of connectors are required to execute your ADF? But how can I install those libraries? How can I install those libraries? All right, then we'll use the percentage sh command. We'll use the magic command percentage sh. Right? Yes, if you want to execute some shell programming, right? Shell programming, then we'll use the percentage sh. Percentage sh means yes, you can execute your, you can do that installation. Basically, you can do that installation of your Python libraries. Any libraries you can, if you want to install, will go with the percentage sh. The default languages are, right, the four default languages, but inside the notebook you can use percentage run, you can use percentage. For example, I want to perform some HTML code related, right? Maybe that header information I want to put into the proper HTML. Maybe I want to type some code, I want to develop one notebook, but inside the notebook I want to come up with proper write-up information. All right, I want to include the URLs information. I want to put into the proper tabular format your content. Then I can use the percentage MD, the markup language, right? The markup language also we can use that HTML language also you can develop with help of the percentage MD. Only the default languages are four, but inside the notebook also explicitly you can use percentage MD, percentage run, percentage SH also possible, right? Implement your scenarios. The scalable, right? Right. We have the auto scaling option, right? I mean, you can increase your resource, you can increase your worker nodes, or you can decrease your worker nodes, depends on your data value. Because we have that auto scaling option is available, right? Auto scaling means that is kind of your scale up and scale down, right? Scale up and scale down, scale up and scale down. But if you're considering the especially auto scaling, right? If you're considering auto scaling, right? Again, it'll give the good performance. It'll give the good performance. But if you're 100% sure about your data, then we should not consider auto scaling. Then you should go with the fixed workers. You should go with the fixed workers. If you're going with auto scaling, right? Depends on your data volume. It will especially launch a number of your especially VMs, right? If it is a fixed mint, it will open only that fixed one, right? It will not check the data. But auto scaling always is a good option to improvise your data. Improvise your data loads, right? Improvise your data loads or to speed up your data loads. You're not 100% sure about your data, right? Maybe you're doing the batch processing or real-time data processing, maybe on the same cluster, maybe on the same cluster configuration, same cluster one, the same cluster configuration, right? Definitely your real-time data processing, you will deal with less amount of data, but each and every minute or each and every 5 minutes or 1 hour, you'll do the data processing, right? For batch processing, yes, you will do that only one off, right? I mean, daily one off or daily twice, you will do the data processing, right? Maybe I want to go with the only the same single cluster configuration. Then I can use this, I mean, auto scaling option, right? Auto scaling option, because every 5 minutes or every 10 minutes I want to execute my notebook. Let me go and increase my skill for batch processing, right? I want to increase my configuration because huge amount of data, right? So these are the different types. I mean, these are the features of your Spark. These are your features of the Spark, right? The Spark runs up to 100 times faster than your Hadoop MapReduce. Right? It is also MapReduce is also one type of process engine or compute engine or framework. But the MapReduce, right? Hadoop framework, right? Hadoop related, Hadoop ecosystem, right? Hadoop. Now we are talking about Azure ecosystem, Databricks ecosystem, right? The same way we have that Hadoop ecosystem. In the Azure point of view, that internal format, right? ADLS, right? Azure Data Lake Storage, either Gen 1 or Gen 2. But Hadoop HDFS, Hadoop Distributed File System, right? The distributed, right? The first distributed file system is that Hadoop only, right? But they were used to map reduce operation, all right, especially for large scale data processing. Right? Even it is also able to achieve the speed through controlled partitioning. Even you can increase your number of partition. Even you can, I mean, you can controlled especially the speed with the help of your auto scaling also. Even you can increase your number of partition. If you increase the number of partitions, definitely you will see the good performance. You're having the huge amount of data, right? You're having the huge amount of data. You can split the data into the n number of partitions, right? N number of partitions, right? The powerful caching, everything can put the data into the Spark in memory, right? From that in memory, you can take the data on top of it. You can apply the transformation. Each and every operations, no need to go to that your hard disk, right? No need to. The deployment that you can develop the Spark code, you can execute the Spark code in any ecosystem with the help of especially these deployment models or resource manager or cluster managers. Even you can do the real-time data processing, right? The low latency, right? Because it is a in-memory computation, right? It is a in-memory computation. If it is not in-memory computation, again it is a time-taken process. At each and every time we should go to the main, I mean not main memory, that hard disk where the data is available. I should take the data, then I need to process again. I need to write the data into that again hard disk, take the data. On top of it, I want to apply the transformation. Again, I need to go to the hard disk. So why should why should I increase my read and write operations in my hard disk? But I want to do that only once read, once write, right? I don't want to perform multiple reads, multiple writes in my hard disk, right? But Spark, it is a in-memory computation. But because you have the powerful caching, only you can read the data from your hard disk once, you can write the data to your hard disk once. The polyglot, right? The Spark provides high-level APIs, right? Like your Java, Scala, Python, and Arc. right? Any of these four languages, right? Even it also provides a shell in the Scala and Python. You have that percentages which, right? Percentages which is available. With help of the shell programming, you can execute, right? You can execute, especially any. I mean, you can execute your libraries. You can import your libraries. You can install your, especially the Python libraries or Scala libraries or some XYZ libraries which are required to support your code, right? Maybe those are not inbuilt. Those are, for example, if you're talking about regular expressions, right? Why we are importing import RE method? Because RE is not a inbuilt library or input module. Explicitly, we have to import because that libraries are available in Python, right? Not in inbuilt, right? Not a default. Explicitly, we have to import. Then we should use that regex, the match function, or full match function, or search methods, right? To implement those scenarios, we are using that import RE method, right? Import the same way. In case we want to install some explicitly libraries or right, maybe the softwares. If you want to install, we'll use the percentage sh command. We'll use the percentage sh command. Right. So these are especially your component like Spark SQL, structure streaming, lib graphics, the core API components. With the help of these four programming languages, we can implement these different use cases. Right? Already we discussed, right? Even you can use the Spark SQL, Spark streaming, machine learning, graphics, and Spark Car. These are the different types of high-level APIs. Means your programming language. With the help of this programming language, we can implement. With the help of this Java programming language, we can implement the Python or R programming language also we can implement these use cases. But in the Databricks, right, we are not using the Java. Java is not a default language, right, not a default language in the Databricks. Either we'll use Scala or Python or SQL or R programming. Clear, right?
Yeah.
Right. Again, this is same write up about your Spark core system. Okay. So yesterday we discussed about the especially fruits.txt file, right? We read the fruits.txt file and we have implemented the counting method, right? We have implemented the counting method to count how many apples, bananas, mangoes are available, right? If you are using the MapReduce program, but how it will execute the backend, right? How it will execute the backend. From that MapReduce also, you have the your main program or your master node, the master node, right? The main program or your master node, right? From the master node you will execute, right? You will execute your code, right? You will execute your code. For example, there are two blocks, right? Each block 128 kb, right? Each block 128 kb. Your master node will connect with your slave nodes, right? It will connect with your slave node because it is a distributed processing, right? Even MapReduce is also distributed data processing, right? Distributed data processing. So what it will do, because the last two boxes are, it will talk about your slave node or your executors, right? The slave node. From the slave node, your main code will execute. From the slave node, your main code will execute. Your master node will, it will take the request from user, right? It will take the request from the user, then it will execute the code with help of the slave node. Slave node with help of the slave node. All right, what is the step one? The step one, we are reading the data. All right, we are reading the data. I mean, we are loading the data into that in memory, right? abc.txt, right? The block one, right? abc.text, right? The block two, right? The block two. Right? This is from your hard disk, right? This is from your hard disk. Means your Hadoop hard disk, I mean Hadoop backend, the virtual machine hard disk, because it is reading the data from your main input file from XYZ location, right? And it will load the data into the each and every block, right? Block one, it contains 128 KB data. Here the block two contains remaining 128 KB data. Right, here half data, here the top data. So what is the next? Right, the next, it should read the data from abc.txt, then it should perform that operations, right? It should perform that operations, right? What kind of operations? Right, let me load the data into in memory. Let me load the data into in memory. Right, this is your physical, right? This is your back in the physical virtual machine hard disk, right? It will take the data and it will dump the data into the in memory. Here it will perform the transformation. Just I'm putting into the what kind of transformation? Maybe that mapping, right? That mapping, maybe I want to do the sorting and the shuffling, right? I want to do the sorting and shuffling. Here also same logic, right? Here also the same logic. Here also the same logic. The step one, we are creating, right, sorting and shuffling. We are executing sorting and shuffling, right? We are arranging apples, bananas, mangoes. We are arranging. We are providing the 111, right? We are providing that 111, right? Then what is the next? It will take the data into the in memory. It will execute the transformations, right? It will execute that operations, that operations, right? Means operation nothing but your transformations, right? You have executed your logic, right? Now this logic output again you're writing into, in memory. This is called your, again you're writing into your in memory. Again you're writing into that in memory, right? Again you're writing into in memory. There are two writes. There are two writes, right? That again, what is the next? Now all ones are available, or ones are available, right? I want to do the maybe sorting and shuffling. Then again the data I want to put into that main memory, right? Again I want to read the data from write to, I mean the write to output. Again I want to read the data into the in memory, right? That is called your, just as them T2 operations. T2 operations. The same concept, the same concept for your B2 also, right? It's the same concept for your B2 also, right? The same concept for your B2 also. Right, again the final output will write the data into the hard disk, correct? That inside the hard disk, right? These are your in memory, right? If you're performing a number of operations, if you're performing that in number of operation, that in number of operations you will execute in memory, but that each and every operation output again you're writing into that hard disk. Again, for example, if you're applying that five operations, five read, five write operations, right? Unnecessarily you're taking the too much time, right? Each and every time why should I go and write the data into that, especially hard disk? But the map reduce will do the same concept, right? Map reduce will apply the same concept, because it is not an in-memory computation, not like your Spark. It will read the data from your internal hard disk. It will take the data into that in memory. It will execute that operation. That operation output it will write into that again your hard disk. From that hard disk again it will take that operation output, and it will apply another transformation. That another transformation output again you will implement into the again your hard disk. If you observe in this diagram, right, there are many read operation, many write operations, right? Right, many read and many write operations, right? Means each and every time you're traveling to your hard disk, right? Each and every time, each and every operation output that you're traveling to your hard disk, each and every data reading operation you're traveling to your hard disk. There are too many, I mean, read and write. I mean, there are many read and write operations. If you, many IO operations, right? In case if your process contains many IO operations, right? Always you're reading the data from hard disk to in memory, hard disk to in memory. 100% your code will end up with performance issues. That's why people always will minimize IO operations, right? If you want to improve the IO operations, then they will think about any in-memory computation. If it is in-memory computation, then you will see the good performance. Even your HANA also one of the in-memory computation, right? I mean, you have that, especially, I mean, physical, I mean, primary server and secondary server. Right? Primary server means your cache, right, in memory. The secondary server means your hard disk, right? Because the problem, right, every data we can't put into that, especially in memory, right? Which of the data is required, we'll put into that in memory. If you're reading the data from your primary server from that in memory, you will see the good performance, your select statement. If the data is available in the secondary server, definitely you'll see the poor performance. The same concept. The map reduce, right? The map reduce. Right here, these are the operations, right? What are the operations? The step one, we should read the data, right? We should read the data from file. The second operations, right? Arrange the data, right? Arrange the data, right? Arrange the data. Then generate, right? Generate some sequence number, right? Sequence numbers like 111. Then you have to do the right? You have to do the shuffling, right? You have to do the shuffling from in within block or multiple blocks. Within block or multiple blocks. Multiple blocks means you are doing the consolidation, right? On top of it, you need to perform the aggregate calculations, right? On top of it, you should to perform the aggregate calculations, right? Calculations are to get the your required output. So these are the kind of your operations. If you want to perform the operations, yes, these operations will execute in memory, but the second, for example, the second operation, arranging the sorting, right? It will take the data from the abc.txt. It will create, it will execute the operation in memory. The sorting output again, it will write the data into the hard disk. Then the next operation, generate sequence number. It will take that output from the sorting output from hard disk. Then it will dump the data into that memory. It will generate the sequence. Again, that output, it will write the data into the hard disk. There are many read and many write operations, right? Many read and many. If you are increasing many read, many write operations, definitely you will see the slowness, right? Maybe it is a distributed data processing, parallel data processing, but still you will see the poor performance. Still you will see the poor performance because of the multiple I/O operations. It's not a in-memory computation. Your MapReduce is not having that any powerful cache, right? Not have a powerful cache. Cache means it is a in-memory computation, right? Or at the fastest access location, right? If the data is available in memory, right? If you're executing any queries, right? Your query will execute very quickly because the data is available in memory. No need to travel to your hard disk. The backend, your cluster configuration hard disk, no need to travel. The data is available, everything in memory, right? Because it is a near location, right? Near location, right? But your hard disk is a very far location, right? Right. The low level latency, right? If you want to implement the low level latency, always you should think about in memory computation. Always you should think about in memory computation. So these are the especially disadvantages in your map reduce. But the same example, right? But here also there is no, for example, the block 2 was failed while doing the data processing. Maybe the second slave node was failed. Then your entire program will fail, right? But there is no fault tolerance. Or there is no, how can you do the recovery, right? How can you do the recovery? Again, we should start from that fresh, right? There is no replication factor. There is no proper replication factor is available. There is no proper replication factor is available, right? I mean, the fault tolerance, right? There is no proper fault tolerance concept, right? In case of the same program we implement in the Spark, right? The master nothing but a driver. The master nothing but a driver node. The master nothing but a driver node or master node. It is a node architecture like your SQL DW. It is a driver node or master node. Right here you will see the multiple boxes. Right. Let me take only two boxes. This is your worker node or executor. This is your worker node or executor or your slave node. Your worker node or slave node. Like in the SQL DW, this is your compute node, this is your control node, right? The driver node, nothing but your control node. The worker node, nothing but your compute node, right? Here, you will execute your proper MPP, right? The same architecture, maybe the terminology is different. The terminology is different. Maybe in the Azure SQL DW, at maximum we can create the 60 servers, right? Here, you can create a number of servers. That is also one of the advantage, right? That is also one other advantage, especially from the Spark. Even the SQL DW also, it is a for parallel data processing, right? Distributed data processing also, right? The same query will split into that multiple servers based on your data warehousing computes, right? Your CDWs or DWCs, right? Based on your compute data warehousing or data warehousing computes. Depends on your configuration. It will create either 60 or 30 or 40. Right here also, yes, in the Spark also we can increase a number of workers. You can increase a number of your VMs also, right? Right, what is the same step, right? The same process, right? The same process here. Driver node with help of the cluster manager, with help of the resource manager, it will split the right process into two workers, right? Maybe your configuration is having the two workers, the data will be split into the two workers. Two workers. Inside, you have the 10 number of stages, tasks, executors are available. So I'm not talking about in detail. So what is the next one? Especially in the Spark, right? The Spark, only the one time it will read the data into here abc.txt. abc.txt. Right, I'm reading the data, right? Reading the data from abc.txt, reading the data from, because the data is now loaded into your Spark virtual machine, right? Because maybe the physical data is available in ADLS. From the reading, it will keep the data into their own hard disk, right? Their own hard disk. That's the backend process, right? Physically will not read this entire is the backend process. Now I have loaded the data or at block 1, block 2 inside the two worker nodes. What's the next? The second step, right? The step one, loading the data, right? This read the data from hard disk, right? The data from the hard disk. One read operations. Okay. Reading the data from the abc.txt from the two worker nodes, right? The data it will kept into in your in memory. In your in memory. Now the data is available in memory, right? Now the data is unavailable. What is the next, right? What is the next activity? What is the next activity? Right, what is the next activity? I want to perform the transformations, right? Transformations. Maybe I want to arrange the data, right? I want to arrange the data. I want to arrange the data. Maybe I want to apply some sorting method. All right. Then the sorting will execute on these two boxes, right? Sorting. Then that output, it will not send it to that hard disk. That output is still available in your in memory. What is the next? The next, right? Right. Generate a sequence for each and every row, right? For each and every row. Right? For each and every row, I want to generate the sequence. Right? The sequence, right? Again, will implement into that in memory only. I mean, it will take the data from. It will take the data from. Let me give this is a T1. This is a T1 from this worker node. This is a T2. The same way, this is your T1. This is your T2. Right, that operations, right? That operations, the T1 operations executed. It will not write the T1 operation data into hard disk. It will keep the data into the in memory. So what is the next activity, next transformation in your code? The next that I want to generate the sequence. This T2 will take the data from the T1. It will apply the transformations logic. Now T2 is not reading the data from that hard disk, right? That next immediate availability location, right? The next only, right? The T1, T2 both are together, right? Into that in memory. So no need to travel to again inside that hard disk. Now both are set together, right? Into that in memory. It will take the data from the T1. It will execute. Right here, the round trip operations will be reduced. Right, round trip means reading again, writing into that in memory, reading from hard disk again, writing into the memory. Especially this travel time we can reduce. Right, this travel time we can reduce because this is a next availability location. Right, everything the T1, T2 are available into that in memory. Right, they can talk to each other, right, quickly, right? If the data is available, again the T1 data, if I'm writing into the hard disk, right, if I want to implement the T2 operations, reading again from the hard disk, it is a time taken process. Here, high latency, right? Within the same virtual machine, still it is a high latency, right? So why should I spend too much time, especially to read and write operation from hard disk to my memory? But your Spark, it is a in-memory computation. It is an in-memory computation. Right, what is the next one? The next one maybe you're performing some kind of shuffling, right? So kind of shuffling, right? Shuffling, right? The next one you're applying the some kind of count function, count function. Then you're writing the data, right? Write the data, write the data, right? You want to write the data. Right, the next T3, T4, T5, right? Everything will be executed, right? Everything will be executed in your in memory only. Everything will be executed in memory. The final output, right? The final output only, it will send the data to your hard disk. But at the final output, right? The final output only it will send the data to main hard disk. Only it will read once, it will write once. But the previous, I mean, especially the map reduce, there are many multiple IO operations, right? Multiple IO to work on multiple IO operations, right? Spark executing all the operations, especially in memory, especially in memory. Right. Moreover, the Spark is a lazy evaluation. If you're executing these transformations, right? If you're executing the because always it is right. If you're reading the data from the hard disk, you will not see the data. If you're arranging the data at this stage, you will not see the data. Here, generating the sequence. These are the transformation. So this is your action, right? Right. The count is to get that output, right? This is called your action. This is called your action. In the Spark point of view, right? This is called your action. These are your transformations. These are your transformations. We'll discuss in detail what are the transformations. These are called your transformations. These are called your transformations. These are called your transformation. The 1 to 4 is your transformation. The fifth is your action. Transformation. Transformation. That is M, not M. These are the transformations. Because the Spark, it is a lazy evaluation. It is a lazy evaluation. What do you mean lazy evaluation? It is a Spark. It is a lazy evaluation computing. Evaluation. It is a lazy evaluation. What do you mean lazy evaluation? Right. If you're performing this 1, 2, 3, 4, right, immediately these 4 steps, it will not hold any data. It's a kind of logical representation. It is a kind of logical representation. If you read the data from the hard disk, arrange the data, generate the sequence. If you're executing this third step, right, you will not see the data. You will not see the data. Once you're executing your action, you're on top of it, your transformation, then only your transformations will be activated. Then only your transformations will be activated. Otherwise, this is a kind of your plain representation, right? The kind of your logical representation. Like your user defined function. Just tell them like your user defined function, it will not be activated, right? Only the definitions you are registering. Once you're calling out your user defined function, then only your UDFs will be activated, right? Otherwise, the kind of skeleton, right? The kind of skeleton, right? Yes, you're executing the count, right? Because that operations like this only, right? That operations will be like this. That operations will be like. Once you're executing your count, right? Yes, you're executing this count on top of it, you're shuffling. On top of your shuffling. Then the shuffling is dependent on your third step. The third step is dependent on your transformation. The transformation is dependent on your first step. Because you will see the proper dependency. If any one of the step failed, right? Any one of the step got failed, it will not continue, right? You will achieve the 100% dependency. Right? You are writing some complex transformation. Each and every transformations are having the dependency. Right? Each and every transformation are having the dependency because your Spark is lazy evaluations. Right? Your transformations are equivalent to your user-defined functions. It's a kind of logical representations. Right? You're only defining that code. You're giving that instructions to your Spark. Okay, this kind of transformations I want to implement. This kind of transformations I want to implement. Once you're executing your action, right? We have the couple of actions are available, like your count, collect, show, write operation. We have the couple of actions are available. If you're executing on any action on your associated transformation, then only your transformations will be activated. Then only your transformations fill the data into your physical memory. Otherwise, it will not fill the data. If you're executing sorting, right, immediately the data is not available. This is a kind of only the logical representation. Once you're executing action on fourth step, right? The fourth step completed, maybe in between you're executing fourth step, like aggregations. Aggregations like your count, some average you're executing, right? Aggregate plus shuffling plus aggregations you're executing, right? Shuffling plus your aggregation you're executing, right? But the shuffling aggregation, it will not hold the data immediately. Once you explicitly execute any action on your transformation, then only it will hold the data. But the shuffling aggregations are dependent on third step, right? Dependent on the third step. If you're for example, I'm executing 4 dot count, but here 4 is not having the data, right? Next, it immediately will go to the fourth step, right? It will check, okay, are you reading the data from the direct? No, I'm dependent on third step. Then it will jump to the third step. Then it will check, are we reading the data from the here? Are we generating the data here? No, I'm dependent on the second step. Then it will go to the second step, right? Do we have the data here? No, I want to go to the first step. Then all the steps will be activated one by one. You will achieve the proper dependency. You will achieve the proper dependency. Spark is a lazy evaluation. You can execute a number of transformations. If you want to activate your transformation, you have to use the action. If you're not using the action, your transformations will not be activated. You can, like, it is equivalent to as is your user defined function. As is your user defined function. Clear, right? Okay, the next that important point, all right, the fault tolerance. For example, here I have that 4 workers or 5 workers. All right. In this example, I'm using the 2 workers, right? Maybe this worker was failed. This worker was failed. In the previous example, one of the worker was failed. All right. Definitely the program will fail, right? That program will fail. So what kind of load balancing you're managing, right? What kind of load balancing, right? What kind of clustering you're managing, right? So what is the alternative? Okay, if that this worker is failed, second worker is failed, what is the alternative? What is the alternative? All right, you want me to stop the program? If for example, because we are dealing with a huge amount of big data analytics, right? Inside the big data analytics, one of the worker was failed, right? But what about your entire operation? Maybe the 19 percentage your data operations are complete. Only one of the worker was failed. For 1%, you want me to, I mean, discard this entire 99 percentage operations. That is wrong, right? What is the advantage of the Spark? That is called fault tolerance. That is called fault tolerance. While defining your configuration, while defining that internal configuration, you should select your replication factors. You should select your replication factor. You should select your replication factor. You should select your replication factor. If the replication factor equal to 2 means, for example, I'm selecting the 2. All right, I'm selecting the 2 means this worker node data will be available in 2 more workers. 2 more workers. For example, this worker and 1 more worker also available. 1 more worker also available. If this worker is shut down, for example, this worker is not active, not active, right? For this worker is not active, maybe inactive. The cluster manager or resource manager responsibilities, it will check what is that alternative, right? The replication factor. Okay, this worker is offline or unavailable. What is that alternative? What is that alternative worker? Right now the replication factor equal to, right? Then it will go and execute that alternative worker with the same configuration, right? The same configuration is each and every worker the same configuration, right? If it is offline, if it is offline, maybe due to some XYZ issue, maybe it was shut down during the data processing, immediately it will activate other worker. Then it will talk to the other worker. Your parent worker was in offline. Could you please execute these operations? That cluster manager responsibility. The cluster manager responsibilities. So this is called your fault tolerance. This is called your fault tolerance. If any worker was failed, right, obviously it will take the second worker based on your replication factor. If the replication factor 5 means 5 workers are available. Maximum I think 2 to 5. They will take the 2 to 5. That depends on your project. That depend. This is our internal setting. These are the internal settings. But maybe explicitly will not define these settings. These are the internal based on your cluster configuration. If it is a replication factor equal to, right, maybe it will execute the same code, right, into the 2 worker nodes. I mean, the same time it will not execute. If it is offline, immediately it will request please execute this task. From the 2 replication factor 2 means the 2 worker nodes, it will not execute. Unnecessary time taken process, right? Unnecessary time taken process. In case the second worker went offline during the process, right? During the process, it went offline. But the cluster manager, it will check, right? Okay, this worker node is active at this stage. It will submit the request. While doing the data processing, it was failed. Immediately, right? It will copy that entire output, the transformations into the second worker, or maybe it will execute the same code, right? But the previous example, we don't have that option, right? The fault tolerance concept is not available here. The fault tolerance concept is available. That is called RDT, a resilient distribution data set. Resilient means kind of your fault tolerance. But Spark is a lazy evaluation. Spark is a Spark will support your fault tolerance concept. So because lazy evaluations, right? Lazy evaluation means the combination of transformations action. Your transformations are equivalent to your user defined function. Like in the Python, we define that UDFs, right? If you define that UDF, it will not execute that code, right? If you explicitly execute, right, your UDF means you're calling out UDF, then only your UDF will activate it. Otherwise, the UDF only will be registered, right? If you need, you can call out. Otherwise, don't no need to call out, right? If you're defining, if you're not calling out that that user defined functions code, it will not be registered. That output it will not be registered in your Python, right, or in your database, right? The same concept, right? The lazy the transformation, nothing but it is a user defined function. If you are executing transformations on associated action, then the flow will be activated. The flow. So the direction, right, from fifth to one. Then it will take the data. Then the second step will execute. Already the second step is registered, right? Then reading the data. Immediately it will execute. Immediately it will execute. Immediately it will execute. Immediately it will run the counter. Then you can write the data. So this is called your lazy evaluation. Any doubts? Yes or no?
No, Anna.
No, no.
Okay, super. Okay, but this is very, very important. So there's a backend process. There's a backend process. Just, I mean, in case if you're good at SQL DW, this you can relate. Driver node, nothing but a here control node, or at worker node, nothing but here compute node. Even the SQL DW also node-based architecture, right? Already we were discussed, right? It is a node-based architecture, right? But in between you have that massive parallel process engine, right? Here the cluster manager, right? Or resource manager. Where I mean the control node will connect with your MPP engine. That MPP engine will distribute the data to multiple workers. Right here, the distributions will be done by your resource manager or cluster manager. Right, the cluster manager response. It is kind of gatekeeper, right? Kind of gatekeeper, right? Kind of gatekeeper to your all the worker nodes. It will check each and every worker node status. Okay, this worker node is occupied with how much, right? Size, right? Do we have any sufficient space to execute second request? Right, it will keep on check all the worker node status and that availability. Yes, this worker node is availability, right? Then it will go and submit the request to this worker node. Okay, this worker loaded with huge amount of, I mean, huge load. Then the next request it will not submit. Once this worker node is free up, right, then only it will submit the request. Correct. So this entire process is called RDD. I mean, the fault tolerance nothing but here RDD, resilient distribution data set. Resilient distribution dataset. The Spark, that initial version, the Spark 1x component is RDD. From Spark to X rate, so they concentrated on the structured data, not only unstructured data. Yes, I want to do I want to put more concentration on the structured data. I want to perform the batch processing. I want to do the structured streaming, right? Structured streaming, not only for unstructured data, right? From the Spark 2.0 onwards, that they implemented a special data frame. Right? It is equivalent to your table. So this Spark working flow. I know this is theory only. You will not get interest, but this is very very important. Okay, we back to. Alright, so this is the working of the Spark architecture. This is working of Spark architecture. The step one, that user, the lake, the same example we discussed in the SQL DW architecture and SQL, right? The step one, user will submit the request, right? Means user will develop the code. While executing means while submitting the request, right? All right, while submitting the request, right, from that master node or the driver node, either master node, driver node, right? That initial entry is the Spark context. The Spark context is available inside your driver program, right? Inside available in your driver program or inside available in your master node or driver node. It will create that request. It will register the request in the master node, right? Spark session or Spark context, SC or Spark session. Right? It will take the request. The request will be registered in your master node or driver node. What is the next? The driver node, it will take the request. It will convert the request into the Spark language. That may be internal, not Spark language, internal language. Means the logical execution, the physical execution, logical execution. It will convert that entire program into the direct acyclic graph into the especially your master node driver node, right? Then it will create a number of executors stages and tasks, right? Those will be created into that worker node. The I mean the Spark context or driver program will take the request from that user. It will convert the request into internal language. Internal language. That request will send to that cluster manager. It will ask the driver program, it will request to the cluster manager, could you please execute this request? The request is converted into our native language. Could you please execute this request with the help of the worker node? The cluster manager, resource manager responsibilities, it will check how many workers are available. What is my input request? So this input request shall I submit it to that how many workers? Right, how many workers? If 5 workers are available, right, it will launch that 5 workers. It will launch that 5 workers. It will distribute the data to 5 workers. If it is available only the three, it will distribute the worker to the three only. Inside your because your main code, your transformations, the majority code will execute on your worker node. Your entire operations will execute on the same like your compute node, right? Like your compute node, your entire all that operations will be executed on your worker node. In case if you are executing any operations, driver program related, right? At that time you need high configuration or your driver program. 99.9% people will not run, especially the driver node or master node operations, because it will contains less memory, right? We should not fit our data into the master node or driver node. If you fit right, definitely you will encounter memory compute issue, right? Memory computation issue. Memory computation issue. Right, the worker node again it will split the data into stages. Worker node or executor both are same. Right, it will create a number of executors, a number of tasks, a number of stages, a number of caches. It will create. It will execute the request. The request again it will send to the cluster manager and the master node, or few of that operation directly it will connect with master node with worker node also possible. That output directly we can send to here. We can send to from worker node to driver node, or driver node also few times it will connect with the worker node. Your mainly your driver node responsibility, it will give your notebook status, whether it is running, whether it is cancelled, whether it is failed. All right, each and every the cluster attached, the cluster attached to the your notebook, right? The status will checked by your driver program, but your entire code will be executed onto the worker node. It is equivalent to like your compute node in the SQL DW. It is equivalent to, because your entire code will execute on your worker node. In case if you are having that any performance issue, you should think about how to improvise your worker nodes. But you're writing some complex operation on the master node work driver node, right? Then you should increase your driver configuration or master configuration. So this is the high level working of the Spark architecture. All right. See here, inside the driver program, the first thing you do is you create a Spark context. Assume that Spark context is the gateway to all the Spark functionality. It is similar to your database connection. Based upon it will create the connectivity, right? It will create the connectivity from the your driver program or master program or your driver node. Any commands you execute in your database goes through the database connection, right? Likewise, anything you do on Spark goes through your Spark context, because this is the initial entry, right? The request should come from your Spark context. The Spark context will be registered on your request. From that request, you will execute your entire throughout your program. Now this Spark context works with the cluster manager or resource manager to manage various jobs, because your entire program is converted into the native code, right? That is nothing but your job. That is nothing but your job. The driver program and Spark context takes care of the job execution within the cluster. A job is split into multiple tasks which are distributed over the worker node, right? Because with help of the cluster manager, the job will be split into multiple, right, multiple worker nodes. From the each worker, you will see the multiple tasks also available. Depends on your transformation, right? Anytime an RDD is created in Spark context, it can be distributed across various nodes, can be cached there because everything it is in memory, right? Because each and every operation, so that each and every operation, the backend that RDD will be created. That is a low level API. The Spark default, if you are executing any transformation or any operations, default that RDD will be created. Resilient distribution data set. It is a fault tolerance rate. The worker nodes, your majority code will be executed on worker node. That alternative name is your slave node. Your driver node, nothing but your master node, your worker node, nothing but your slave node, or your executor node, or your main execution code will be done inside the your worker node. Alright, whose job is basically to execute the tasks. These tasks are then executed on the partition RDDs in the worker node and hence return back the result to the Spark context. Means your driver node. Because your worker n number of tasks, right? N number of tasks means n number of partitions will be created. Partition RDD will be created. Right? The distribute 5 partitions means you're distributing your data into the 5 partition RDDs, right? It will execute, it will collect that output from the 5 partitions and it will send the data back to your driver node. That is called your Spark context. Right? The Spark context takes the job, breaks the job in tasks and distribute them to the worker node. The task work on the partition RDD or perform operations, collect the results and return the main Spark context. Means your driver program. Because your Spark context is kind of your connection, so kind of initial entry, it will register your request into the driver node program. The program it will convert the request into the native code, right? The native code. I mean, that is a kind of your DAG. If you increase the number of workers, then you can divide jobs into more partitions and execute them parallelly over multiple systems. It will be a lot faster, right? In case if you have the huge amount of data, then you can go and split the data, right? You can go and split the data into multiple workers, right? Means multiple machines, right? Indirectly multiple machines. That's why you'll see the good performance. With the increase in the number of workers, memory size will also increase. You can cache the jobs to execute it faster. What it mean? You're creating a number of VMs at backend, and the same like your compute node. If you're increasing your compute node, you will see the good performance, right? But the cost also very high, right? Cost also very high because you're taking a number of VMs helps, right? Right, a number of VMs help. So these are this. Please, I mean, by heart these 4 steps. Or at interview, they will ask the questions. Could you please explain the backend, the Spark, I mean, steps, right? The Spark flow, how those steps will be executed from initial submitting the request to collect your output. See, the client submit Spark user application code. When an application code is submitted, the driver implicitly converts user code that contains transformations and actions into a logically directed acyclic graph called DAG. Directed acyclic graph. Directed acyclic graph. Because your entire code, right, your entire code, it will convert into the DAG. Means you're explicitly writing that code, right? For example, in the database point of view, select star from EMP, right? You're explicitly writing that code. You're submitting the request to your SQL. SQL, it will convert the request into the Oracle server language, right? The same here, the driver program, the Spark context, it will convert the your entire code into the tag. At this stage, it also performs optimization such as pipelining transformation. Here, everything, the default optimization. We have some catalyst optimizer. So these are the default optimizer because the Spark is a intelligent tool, right? But each and every time it will not dependent on the developers, right? The partial performance tuning will be taken care by your Spark because Spark is intelligent tool. Right now, the DAG is created. Right? The DAG is created into the your driver node or your master node. All right. Once the DAG is created, right, what is the next step? After that, it converts the logical graph called DAG into physical execution plan with many stages. After converting into the physical execution plan, then logical execution plan it will create. It created physical execution units called task under each stage. Right? Under each stage, right, you will create one task. In each stage, you will create one task. Then the tasks are bundled and sent to the cluster. Now the driver talks to the cluster manager and negotiates the resources. Then the third step, your driver program will request to the cluster manager. I need to execute this request. Could you please work it out with the help of the worker nodes? The cluster manager, resource manager launches executors in worker nodes on behalf of the driver. At this point, the driver will send the task to executor based on the data placement, or based on your transformations, actions, right? It will execute, it will create the each and every partition RPD, right? When executor starts, the register themselves with the drivers. So the driver will have a complete view of that executor that are executing the task, because everything will be executed under supervision of your master node, right? Because your driver, each and every step it will monitor, because your Spark context is a connection, right? Each and every step it will monitor. It will check the status also. During the course of execution of the task, driver program will monitor the set of executor that runs. Driver node also schedules the future task based on the data placement. Means with the help of cluster manager. With the help of the cluster manager. So these are the backend steps. Once you're submitting your request, right, means you're executing your Databricks notebook, submitting the request, right, you're defining the code. The code will be converted into the DAG, the physical execution plan, logical execution plan. It will create the stages, jobs, executor tasks. Everything will be executed inside the your worker node, but with the help of the your cluster manager. Any doubts?
No, Anna.
No.
Yeah, in case if you don't have any doubts, we'll connect tomorrow. Tomorrow onwards, we'll discuss about RDD. I mean, the practical classes. Tomorrow onwards, we'll discuss about RDD. After RDD, RD is not much important, but still, you'll get more questions on RDD also. They will ask how to create that RDD. See, in interview also, they will, I mean, give some practical questions. So this is my unstructured data. But I want to count so India word is available inside the some abc.txt. How many times that India word is available? All right. So they will ask these kind of programs also in the real time. But 98.9% will not create RDDs, but depends. In case your requirement 100% you want to use that RDD, right? You want to use that RDD, at that time will create the especially your RDD.
That HDFS and this Spark architecture differs only in the shuffle.
Lazy evaluation, right?
Okay, lazy evaluation.
Lazy evaluation, in memory computation, all right? In memory computation, the fault tolerance, right?
Okay.
All right, fault tolerance, right? Even still, people are preferring Hadoop with Spark combination also. Hadoop,
HDFS plus Spark.
right? Hadoop, yeah.
Okay.
HDFS is a file system, right? Because that ecosystem is a Hadoop, right?
Okay.
Like here Azure, we have that ADLS, right? The file system I'm talking
Yes,
about.
yes.
The Hadoop file system is HDFS. Hadoop file system is that HDFS.
Okay, okay.
Hadoop file system is HDFS.
Mapper reducer.
Correct. MapReduce is a like framework, like Spark is a framework, right?
Yes.
Spark framework or process engine or compute engine. The
Okay, it's a
same
framework. Hadoop is a architecture.
ecosystem. Ecosystem.
Okay.
Hadoop is ecosystem. HDFS is a file system.
Okay, HDFS is fine.
Like your Azure, the naming, right? Azure is the name, right? Azure is the name. It contains ADLS, right? It's ecosystem. Azure is the one type of ecosystem, right? On top of it, you can use the different types of components. Here, we are using the ADF, Azure SQL DB, right? In that Hadoop, the components are Pig, Hive,
Yes.
HBase, Flume. there are different types of components are depends on the requirement, right? Even Azure also there are a number of services. It depends on your requirement, right?
I mean, Spark is later version of Hadoop. We can say that like that.
No, there is no comparison between Hadoop and Spark,
Okay.
right? Then you can compare with MapReduce versus Spark.
Okay.
I mean, MapReduce versus Spark.
Okay. I'll.
MapReduce. But
Mean,
still, your Hadoop also using Spark, right? I mean, this combination also available, right? Even this combination also is available. Hadoop with Spark also possible.
okay. The ecosystem will change then.
Correct. I mean, the process engine will change, compute engine will change, framework. So this is framework, right?
Yes. Okay.
Your ecosystem is the Hadoop, right? This is
Mhm.
also framework.
My work is going to be on this majorly.
Hadoop,
Not Hadoop. I mean, Databricks side.
a database, right? Like PySpark, yeah. Not in Hadoop means your but your data is in Azure only, right? You're using Azure Databricks, right? Not
Yes.
Hadoop with Spark, right?
Yes. Yes. Azure plus Databricks.
Right? You're not worried about the Hadoop, right?
Okay.
Here you will talk about ADLS, right? Or Blob, or maybe Azure SQL DB, right?
Yes.
SQL DB. Yeah, main key operations. Mount party will set up. Reading means here your majority code maybe if just go and check your existing notebooks, right? Majority either Spark skill plus data frames. Maybe the language either Scala or Python. If there are already your project is in place, already notebooks were developed, just go and check the default programming language, that is Python or
It's a
Scala.
brand new project.
Sorry, I mean already it is in place, already developed the notebooks or yet to develop.
Okay. Scala is nothing but I mean here and there SQL commands, right?
Correct. So major timing because 99.9 percentage only these two combinations they will use. Spark. If you good at SQL, right, it's very easy. Databricks is very easy. Just
Ah,
you should understand the functionalities. You should understand the especially the naming convention.
okay.
But the same SQL operation, simple select, everything can execute. What are the SQL you know, right? You can go and execute. Maybe additional because it is advanced analytics also, right? Advanced with new functions
Yes,
also
yes.
available in the Spark.
More analytical.
Correct. I mean, you can advanced analytics also you can execute. But if you're good at SQL, right, Databricks is very easy. Just you should understand the utilities. You should know the syntax of the data frame creation. You should know how to create the tables. The rest of the 90 percentage logics in your Spark skill.
Oh.
But unfortunately, in the interview, they will ask all the questions, right? But frankly speaking, once you get the job, right, 90 percentage your operations in SQL only 90 percentage, right?
Mm.
People will not restrict why you are using the skill, why can't you use the data from. Ultimately, their goal, they want to finish the deliverables, right?
Yes,
Then
that
they'll
is.
think about performance tuning also. But the same, either if you create data frame, Spark is both are same.
Okay.
How to improvise your partitions in the data frame, then you should think about how to improvise your Spark skill partition.
Okay. Okay.
But interview, they will ask all the questions, right? What is the data frame? How you will create the data frame? How many ways you will create the data frame? What are the transformations are available in the data frame? How you will perform the inner join? What type of joins are supporting the data frame? How will perform the filter condition? How will perform the where condition? How will perform the select? These are all the transformations, right? In the data frame wise, otherwise you can execute your simple select statement with your joins.
In the same project, we use Scala and Python,
Right
or
here you
only Scala or
uh,
Python.
right, what is the default programming language important, right? Default language, right? Maybe 80 percentage you will write your default language, 20 percentage maybe your other depends, right? I mean, for
Okay.
example, in my last project we were executed all the stored procedures in the Scala because unfortunately in the Python it will not return the stored procedure outputs.
Okay.
Maybe we don't have the right connect still. yet to develop those connectors are yet to develop into the PySpark. But what is that alternative? In my previous project, we want to explicitly execute the stored procedure. The stored procedure should return that output. From
Yes.
that output, we want to perform the some kind of conditional
Okay.
checks, like maybe your metadata implementation, just as maybe your metadata implementations, like your meta, like you are executing the stored procedure in ADF, right? Post successful completion of copy activity or failure, right?
Okay.
The same thing we can execute in the Databricks also, right? Even you can implement your framework in the Databricks also, right? But you need tables, right? Azure SQL DB tables. But how can I execute my store procedure? My store procedure should return some output. Maybe lookup, right? I want to act it as a lookup, my stored procedure. And how can I execute? And then we'll use the scalar programming language.
Mm-hmm.
We'll use the scalar programming language. Right? Maybe you will develop the all the stored procedure one in another notebook, the Scala default language. From the Python, you will execute the Scala. You will return that output. That output again you will check in your Python programming language. Or maybe within the one notebook also you will use the multiple combinations.
Okay.
Right? But unfortunately, if you are writing within the one notebook Scala plus Python, right? This data output we can't share to the Python, right? Already we are discussed, right?
Okay. Yes.
But we have that alternative. We'll discuss that alternative. That is also very, very important. Interview, they will ask the questions. Okay, I want to execute one Scala code, but that output I want to use in Python. What is the best way? There are two ways. You can create separate Scala notebook. You can execute the Scala notebook with the dbutils.notebook.run. That output you can assign to that one variable.
Okay.
No, I'm not creating separate notebooks within the notebook, right? You can go and create the Scala within the Python notebook, right? Like one cell you can execute. You can that output create into the Spark table. That output you can create in the Spark table. From the Spark table, I can read the data. Now I'm reading the data from the table, right? The table has been created with help of the Scala or with the help of the Python. I don't care. Just I'm reading the data from the Spark table. But both languages are eligible to read the data from the Spark tables, right? Um, that Hive tables, right? Both are eligible to read the data. There is no restriction. Whether your output you are capturing into the Scala, your output generating with help of the Scala and dumping into the table, Spark table. In Python, I can read the data from the Spark table. So this is the alternative methodology.
Mm-hmm. Okay.
Means maybe your project is not Hadoop system, maybe your project is Azure ecosystem. That's why
Yeah.
you're using Azure Databricks, right? Otherwise, if it is Hadoop means you will not use that Azure Databricks, right? You will use direct Hadoop ecosystem only. If you observe in that ADF, we have that Hadoop component also, right? One activity I'm talking about.
Okay.
All right, Hadoop component also available. I think last but one. I think last but maybe from your activity. Just go and check. Or you will see the pig, you will see the hive, you will see the map reduce also. Map reduce means you should develop your code inside the map.
Okay.
Any other doubts? No, right? Any doubts?
No, no.
Okay, super. Yeah, tomorrow onwards we'll discuss a complete practical, not theory. Okay, we'll discuss complete practical, how to create the RDTs, how many ways to create RDTs. We'll discuss interview questions also from tomorrow onwards. Mostly day after tomorrow we'll start data frame, but data frame is only important in the Databricks. Databricks utilities and data frame, Delta Lake, the Spark skill. If you know these four concepts, right, you can clear any interview. You can develop any complex code also in your project. If you know, I mean, by default Python programming, right? By default Python programming. And I will discuss all the use cases, the complex scenarios also from tomorrow onwards.
Okay.
Thanks everyone.
Thanks.